right? Question first. A gas is held in a piston cylinder assembly at a constant pressure of 300 kilopascal. The initial volume is 0.5 meter cube. If the gas is heated and expanded to a final volume of 0.8 meter cube, calculate the work done by the gas, right? So as we know, here P equals to 300 kilopascal. This is a constant throughout the process, right? So we know the boundary work W equals to P into delta V, integration from state 1 to the state 2, right? So this process, so right? So when we integrate it, so the P is a constant, it will come out from this integration, so only remain delta V, right? So when we integrate delta V, so it's a V2 minus V1, right? From here, if we put this value, so we will get this one and multiply it and differentiate it and multiply it, so we will get at 90 kilojoule. So this is the answer, right? So work done, here work done in the PV diagram, here this is this shaded area, this is the work done by the system, right? This is the work done W. This area, this is the area, this shaded area, this complete area, this is the work done during this process, right? So this is the work done. This area is W. This equals to 90 kilojoule, right? Question number second. 2 mole of an ideal gas are compressed reversibly and isothermally at 400 Kelvin from an initial volume of 15 liter to a final volume of 5 liter. Calculate work done on the gas. Here given R equals to 8.314 joule per mole per Kelvin, right? Here given T equals to 400 Kelvin. This is a constant throughout the process, right? So this is the isothermal process. So boundary work W equals to P into delta V from state 1 to state 2, right? But this process is a isothermal process here, right? So when we integrate it, we will get nR T ln V2 upon V1, right? Here R is a universal gas constant, right? When we put the n number of moles and the value of gas constant R and temperature, this W we can write it 7.3 in 3 kilojoule, right? But work done on the system, negative sign only indicate the work done on the system, right? So we remove this negative sign and say only okay, this is the work done on the system, right? Here next question. A gas undergo polytropic expansion process where n equals to 1.2. The initial pressure and the volume are 800 kilopascal and 0.05 meter cube respectively. The final volume is 0.2 meter cube. Determine the work done by the gas during this process, right? So same the boundary work W equals to process 1 to 2, right? Initial means state 1 to 2 P into delta V. When we integrate it, right, in a polytropic process means here P V keep our n equals to constant. So when we put this P value here and integrate it, so we will get this expression, right? So as we know, this point state 1 and state 2, right? Here these value right here these point are lie on this curve, right? PV की power 1.2 equals to constant. So this will satisfy this equation, this point, right? This is equal to C. So from here we can calculate P2, right? P2 we will get 151.57 kilopascal, right? So then we will put these value in here, right? We know this is P2, this is V2, this is this is P1, this is V1, and this is 1 minus this is N, right? So we will get 48 kilojoule because pressure is kilopascal. So here answer will be come into the kilojoule, right? So work done means the area under the curve, right? So here work done during this process 1 to 2, right? 1 to 2, this is here this area under this curve, this is the area, right? This area, right, under this is the work done, right? This is the W equals to 48.3 kilojoule, right? Here last question 4. A gas undergoes two sequential processes, right? Number 1, from state 1, here state 1 P1 it is given 100 kilopascal and V1 it's a 2 meter cube, right? To state 2, here state 2, here only volume is given 4 meter cube, right? The pressure rises linearly with volume to P2, that this is 300 kilopascal, right? This is given. Second, from state 2 to state 3, the gas compressed at a constant pressure until the volume back to the V3, this is 2 meter cube, right? So first part is sketch the cycle on PV diagram, right? So here it is moved from state 1, here this is state 1, its pressure is given 100 and kilopascal, and volume here it is 2 meter cube, right? So this is the state 1. Then it's compressed to the state 2 where volume is given, right, and pressure is also P2, this is also given, this is the 300 kilopascal, right? Then state here it is compressed from state 2 to state 3, right? This is state 3, right, until back to its initial volume. Here this is initial volume, this is its initial volume here, so up to here, right? So this is its initial state, right? So this is the PV diagram, right? So this is P from 1 to 2, 2 to 3. So this is the PV diagram of this cycle, right? Second, calculate total work, right, or total net work for this cycle, right? For net work means any process. For example, for this process 1 to 2, work done equals to the area under this curve. So this is the area for process 1 to 2, right? And for process 2 to 3, work done is area under this curve, right? So under area of this curve, this is equals to this one, right? So this is the work done. So but this work from 1 to 2 and this is the common, so this will cancel out, so only remain work, this is the net work, this is the work, means this is the triangle, right, this triangle. So net work done, W net, when I am writing W net equals to area of this triangle, area of this triangle, area of triangle 1, 2, 3, right? So area of this triangle we know 1 by 2 base into height, right? So 1 by 2, what is base? If this is the base, means here P 300 minus 100, right? This is 300 and this is 100, so 300 minus 100, so this is the 200, right? So this is the base is 200, right? And it is height, this is the height is the this volume, means here this is 4 minus 2, right, which is equals to 1 by 2 into 200 into 2. So this will give 2 cancel out, so we will get 200, and this is in kilopascal, so this is 200 kilojoule, right? So this is the net work done during this process, right? But this is the negative work because this is the compression law, so this is the work done on the system, right? So this will be the negative work, right? So work done on the system, so W equals to 200 kilojoule, work done on the system, right?